So we're told that both x and y are positive, and this is kind of the ranking, which is the equivalent of that inequality. Sometimes we use the number line to visualize things. Question, which of the following must be negative? So y minus x cubed. So the question is, it must be negative under all circumstances. So if you can find a counterexample, that would be one way to negate that. So for example, we know that if x is a large number, for example, most students are going to start with that example, then clearly in this case, it's negative. 1 minus 8 is minus 7. But the question is that always the case? So the key thing is, how do we shrink x cubed? So if we pick a number between 0 and 1, then we know that as we cube it, it will shrink. So for example, if I pick x to be 0.2, and then I have to still satisfy this condition. So y is 0.1, so I do satisfy that. X is greater than y. But then here you'll notice x cubed will become 8, and then we have 3 decimal places back, 1, 2, 3. So 0.008. Yeah, let me just make sure. For some reason, I was like, I want to make sure. So y minus x cubed here will be actually positive. So that negates that because it must be negative, so we know 1 is out. 2, sometimes you have opportunities to rewrite these expressions, so always look to do that if you see that you can factor something out. So the first step I'm going to do is to factor x squared. Largest common term in general will always work. This piece is positive, and we know y minus x is negative because x is greater than y. So this will be always negative no matter what x and y are, whether they are between 0 and 1 or not. So 2 is correct. And then third one, x squared y minus xy squared. Again, I'll factor the largest common term, xy, and then I get x minus y. Here, xy is positive, this product, and this is also positive. So this must be always positive. They're asking which of the following must be negative. So this one is out. The answer is 2 only, choice B.